Let's take a look at this problem. We got sine theta is equal to 1/4, and tangent theta is greater than 0, and we want to find cosine of theta over 2. First off, let's look at our formula for cosine theta over 2. It's going to equal to plus or minus square root 1 plus cosine theta over 2. So it looks like two things we need is we need cosine theta, and we also need to determine what our sines are. Okay, first off, sine is equal to positive 1/4. Now sine is equivalent to our y value, because remember sine is y over r, and r is always positive. So they're saying y is positive, which is these two quadrants. Now tangent is greater than 0, so it's saying tangent is positive, and tangent is y over x. Well, y over x is positive when the signs are the same, because positive divided by positive is positive, which is this quadrant, and down in this quadrant, because a negative over negative gives you positive also. Where they're both true is quadrant 1. Okay, now that's where theta falls. So if theta is in quadrant 1, then half of theta is also in quadrant 1, which means that we're going to keep the positive version of this. So we got 1 plus cosine theta over 2 inside the square root. Okay, well, let's work at getting cosine now. Sine theta is equal to 1/4, and sine is y over r. So we're going to have x squared plus y squared is equal to r squared. So we got x squared plus y is 1. So we got 1 squared is equal to 4 squared. So we got x squared plus 1 is equal to 16. Take the 1 over, and we get x squared is equal to 15. Square root property, drop our squared, put a plus or minus square root on the other side. And we said we're in quadrant 1, which means that the x values are positive. So we're going to have a positive square root of 15. Now realize that the sign of our formula over here is different than the sign of these x's and y's. So you have to keep that in mind. The first part we did right here is what the sign of these x's and y's are going to be. This second part is just determining the sign of our formula. Okay, well, let's figure out what cosine theta is. Cosine is equal to x over r. So that'll be a square root of 15 over r, which is 4. Well, let's plug that in. We got square root of 1 plus square root of 15 over 4 all over 2. Now we have a fraction inside a fraction, which we can't have, so I'm going to multiply everything by the LCM of all their inner denominators. When I say inner denominator, I'm talking about the fraction inside the fraction. So multiply everything by 4. Okay, so we're going to take 4 times 1, and we'll take 4 times square root of 15 over 4. Take 4 times 2, so that's going to give us a square root of 4 plus the square root of 15 all over 8. Now we can't have a fraction inside of a square root, so we'll split this up. We'll put a square root on top, and we'll put a square root on to the bottom. Well, we can't have a square root in the denominator, but this simplifies. 8 is 3 2's, which means the bottom part becomes, top part remains as is, but the bottom part becomes 2 square root of 2, because we've got a pair of 2's. Which creates a different issue, because we can't have a square root in the denominator. So we're going to multiply top and bottom by the square root of 2. So up on top, that gives us square root of 2 times 4 plus square root of 15. Because when you're multiplying two radicals together, you multiply what's underneath the radicals. Put them underneath a single radical. In this case, square roots. On the bottom, we got 2 here, and then square root of 2 times square root of 2 gives us 2. So then I'll multiply that through up on top. 2 times 4 is 8, and 2 times square root of 15 is 2 square root of 15. Yeah, I wrote that wrong. The square root is right on the top. So we got 8 plus 2 square root of 15 all over 2 times 2 is 4. And that would be our answer.